It is an AIPMT 2015 question basing on conservation of energy. The problem is like this. A ball is thrown vertically downward from a height of 20 meters with an initial velocity v0. Let me explain what's the meaning of that. From a certain height of 20 meters, a ball is thrown down with it's not dropped freely, it has an initial velocity v0. It has collided with the ground as it is being said in the problem. It collides with the ground, loses 50% of its energy in collision and rebounds to the same height. Then what is its initial velocity? So what he is saying is, after striking this floor, ball rebounds. Here it could be having some velocity v dash. With velocity it rebounds the same height, that is 20 meters. That means at this place its final velocity equal to 0. So I can calculate between these 2 points x and y what is this velocity v is, right? Between x and y I can write a formula v square minus u square equal to 2as. V square means final velocity. U square means v square equal to 2gh. Of course, a equal to minus g. H is 20 meters. Minus v square equal to minus 2 into 10 into 20. V square equal to 400. V equal to 20 meter per second. So when it is bouncing back, it has a velocity of 20 meter per second. So when bouncing back, it has a total energy, that is potential and kinetic energy. As potential energy is 0 because it is with the ground. Kinetic energy is half mv square. Mass is not known to me, but v is 20 square. That is 400 m by 2. That is 200 m joule. That's the total energy that it has after the collision. But it is said that it collides with the ground, loses 50% of energy in collision. So I can write, before collision, its energy is, this is after losing 50%. That means 2 times of 200 m before losing that 50%. That will be 400 m before. That is before what we have to say. Before losing energy, it has 400 meters. So here it has 400 m of joule, where m is the mass. So according to conservation of theory of energy, even at the point x dash also, total energy is 400 m. What are the energies that it has at this point? It is moving with the initial velocity, so it has a kinetic energy, half mv0 square. It is at a height from the ground, so it has a potential energy mgh. That equal to 400 m, where m is the mass. M is common there, that can be cancelled. v0 square by 2, that v0 has to be calculated. G is 10, h is 20 as it is given, is 400. v0 square equal to 400. This 200 on the other side becomes minus. So v0 square by 2 is 200. v0 square is 400. So v0 is 20 meter per second. So it has a velocity of 20 meter per second initially. So all these things will happen, right? So I have used a very simple concept to solve this problem, very basic aspects. Basic aspects that I have used is, it is said that even after losing 50% of energy, it has bounced back to the same height h. Taking that into consideration, I have first found at the maximum height its velocity is 0. Here it is having velocity v. So here at the point, at the base, after rebouncing has a velocity v. So after bouncing back, it has a total energy of 200 m. This is after losing 50% of energy during the collision. So obviously, before losing, it shall be having 100% of energy, that is double to this. That is this 400 m, where m is the mass. If here is 400 m, according to conservation of energy, here also 400 m. Total energy is 400 m. That total energy is sum of kinetic energy because it's moving, potential energy because it's at a height from the ground. So I have used conservation of energy 400 ms, sum of potential and kinetic energy, and I have simplified that, and I found that the velocity is 20 meter per second. That's how we solve the problem. Thank you for watching.